In this video, we're going to do a couple examples of finding the area under a curve using geometric formulas. Now, in 501, I did an example using a piecewise function that involved triangles and trapezoids. This one is a different shape. This is the definite integral from 0 to 4 of the square root of 16 minus x squared. Now, if you don't recognize this right away, this is actually a circle. So let me just look at this function by itself for a second. Let's remember that f of x is actually y. And if we do some algebraic manipulation here, let's square both sides, get rid of that radical, and then add that x squared to the other side. That is the standard form equation of a circle, where the center is 0, 0, because the standard form equation looks like this. And you probably learned that in pre-calc, if not algebra 2. So in this case, the center is 0, 0 because there's nothing being added or subtracted here. So this positive radical here actually just represents the top half of our circle. If it was negative, it would be the bottom half. So now if you look at what this is asking, it's basically asking you to find the area of this semicircle from 0 to 4. 0 to 4, that would be 1/4 of the entire circle. So we're only looking for this section. So 1/4 of pi r squared, our radius is 4, and this is 1/4 of 16 pi. So the area is 4 pi. Pretty straightforward. This one's a little trickier because it's not quite apparent that this is a circle as well, but it is. Same thing. So here's our f of x, change that to a y, square both sides. Now let's add this whole piece to the other side, make it positive on the left. So now x minus 4 squared plus y squared equals 9. Remember that x minus h, that is the x-coordinate of the center of the circle. So this is another circle, but it's actually been moved. The negative sign means it's been moved to the right. So the center of this circle is 4, 0, and it has a radius of 3. So here's our center at 4, 0. Radius of 3 takes us to 7 this way, and 1 this way, and 3 this way and this way. Doesn't matter about the bottom though, because again, this is the positive radical, so we're only concerned with the top half of this circle, and from 1 to 7 represents the entire semicircle. So we just want to know the area of a semicircle in this case with a radius of 3. So we end up with 9 pi over 2.